Hello students, now we are going to study about the numerical analysis with the paper 6B of the 5th semester B.Sc mathematics. So the first topics that we are going to study about this in this chapter is approximations. So before jumping into the actual topic, let us see some of the basic things. Let's see about the numbers first. So in numerical analysis, we are considering only two type of numbers. One is exact, the second one is approximated numbers. The approximate numbers. So exact numbers, we know that. Let me take the example for exact numbers, that is 2, 4, 6, 1 by 2, 7 by 2, so on. These are the exact numbers. So what about the exact numbers? See, the exact numbers are which represent the given number to a certain degree of accuracy are called approximate numbers. Let me take one example here. So 4 by 3, we know that when 4 is divided by 3, we have 1.3333. You have non-terminating remainder. Similarly for root 2. So for root 2, I can take this as 1.414213, so on. So if I consider this number, so I can write 4 by 3 as 1.333. I'll restrict the decimal places to only 3 positions. So this is called the approximate value of 4 by 3. This is the what have answer written, that 1.33 is, that is called approximated value of 4 by 3. Similarly, the approximated value of root 2 is, that is 1.4142. I'll restrict the decimal places. This is the approximate value. Approximate number or approximate value of root 2. Similarly, we have a pi. The approximate value of pi is 3.1. We are using the approximate value of pi. The actual value is 3.141592, so on. Still more continuous it. So these are about the approximate numbers. So then we have seen significant numbers in your PUC classes. Significant numbers. So significant. So significant numbers. So we know that what is significant number, right? So significant numbers, to just express the numbers, the digits used to express the numbers are called the significant digits, right? Okay. If I take the example 3.492, so how many digits are there? How many significant digits are there? So we'll write there are 4 significant digits, or 4 significant digits are there. And if similarly, if I take more example, let me take 0.2438. In this example, we are considering only the these are the four digits only, 1, 2, 3, 4. This is 4 digit significant numbers, where we are not considering this 0, the number which the 0 which before the decimal points. So the role of 0 in this case is that this is used to fix the position at the decimal places. So these zeros are. So we use 0 as used to fix the position at the decimal places. If I take the one more example, that is 0.00368. See how many significant digits you have. Here you have only 3, because we are not counting the 0 which is before the decimal place or after the decimal place. We have only the 3 digits. 3 significant digits we have. Similarly, if we take 0.000268, how many digits are there here? Again, you have only 3 digits. We are not considering the 0 here, which is after the decimal point, so which is used to just fix the position. This is the how many decimal places you have up to the point. 1 2 3 4 5 6 6 decimal places you are, digits are there, sorry, decimal places. So if I take 20.85, so it's now you can count 1 2 3 4 5, so you have 5 digits, 5 significant digits you have, because it is in between the numbers. So we don't have a separate zero and before the decimal or after the decimal. So significant figures, any digits of 1 2 3, so up to 9, and 0 is a significant except when it is used to fix the position at the decimal places. In such cases we are not considering it as a significant, because in these cases we are considering it as a significant numbers, where when it comes to the matter of the fixing the decimal places, we are not considering that answer. So 0 only helps to decimal points. So if I take one more example, 38015, how many significant figures are here? You have here you have 1 2 3 4 5, 5 significant figures you have. So many examples we have. So if you take one more example, that is 0.0000008231, how many significant? Again, it's that three significant figures. It contains only the 3 significance. These are some examples for significant figures. In next topic we are going to study is rounding off. Rounding off. We have come across this in our elementary classes. To round up the figures, you have given some numbers. So you have to round off that. So rule 2, you have following certain rules to round up this significant figures. So let me see what are the rules. So rule 2, round off a number to n significant figures or digits. I can say it figures or digits. So let's see the first rule. What is the first rule? It says discard all digits to the right of nth digit. So first what you have to we want to figure of a number to 3 significant figures. So you have to after the numbers after the digits which are present after the third position, of the third number, the number which are present, you have to remove that numbers. Okay. And the second thing is that it says that if discarded number is or digit, you have 2 possibility here, less than half a unit in the nth place. place, leave the nth place unchanged. Okay. So if discarded number is, so the number which is lies very next to the nth digit, so it is half less than a half a unit in the nth place. Suppose if you have the discarded number 4 and your nth digit number is 9, what is the half of 9? The 9 is 4.5, so it is less than the 4, right? So it is greater than the 4, so your number is less than the half of the digit which is present in the nth place, so you have to retain as it is, you do not change. And if we take the see, the second possibility is that greater than half a unit in the nth place increase the nth digit, sorry, nth digit, nth digit by unity. If it is more than half a unit in the nth place, we have to increase that digit, we have to increase the digit which are in the nth position by unity. That means you have to add 1 to the digit which are in the nth place. Okay, the third possibility is if what exactly half. So if what happens if you have exactly half, so you have to increase the nth digit, only if nth digit by unity, only if it is odd number, otherwise leave unchanged, otherwise we have to keep as it is, otherwise leave unchanged. So okay, these are the three conditions. So if you didn't understand this rule, we can the simplified version of this is that if you are so let me take one example to understand that this rounding of formulas. Okay, let me take, okay, here is a problem. Round off the following numbers to 3 significant figures. So okay, your first problem is that 1.7893, we have to take only 3 digits. See, we take 1.7. okay, third digit is look into the third digit, we have 8 in that. See what that, see, discard all the digits to the right of the nth digit. I have discarded all the numbers which are right to the nth digit. Okay, now look into the coming to the ninth. Say discarded digits. From this I have discarded. I had removed. Let me tell you the remove. Use the word removed. I have removed the that two digits, that is 9 and 3. See, take the first digit. What is that? You have a 9. Okay, less than a half a unit in the nth place. See the what is the, is it the less than a half? What is the half of this? Is half of 8 is 4. Is it less than 4? No, it is greater than 4. So greater than a half unit in the nth place, right? It is greater than the half the unit in the nth. The half of this is 4, which is greater than 4. So that what you have to do, you have to increase the nth digit by unity. So that I have to increase the nth position is here 3. I have to increase this number by 1, so that your number becomes 9. 8 plus 1 is 9. So your new number is what? A rounded off number is 1.79. So one more simple technique we can use here. See, if your number is the nth position number is 8, so after that you have 9, which is greater than 5, right? So if you have greater than 5 number, after discarding, the numbers which are present in the nth, after the nth position, you have to discard them. That if that number is greater than the 8, that number is greater than 5, that number is, if this number is greater than 5, so you add this to 1. So you have to increase, you increase that number by, which is less than 5. For if your number is 3, 2, like that, you retain this number as it is. If this number is greater than 5, you increase this number. If this number is less than 5, this 9 is, if the other number, if you have, if it is 9 number, if you have a number which is less than 5, so you leave this number as it is. Okay, if you have 2.5 or if you have exactly 5, you can increase or you can keep as it is. Okay, sometimes we can increase the number. Okay, will increase when you have a 5. So you will see the second question, that is 12.865. You have to round off the number to 3 digits. So let me write the first 2 digits, add it, look into the third digit. So what is the half of this? Is 4. Half of 8 is 4, right? So which is greater than this, which is less than this number. So that means this number is greater than 6 is greater than half of this digit. Okay, so you have to increase by 1, right? So your number becomes new, or you see number, we use that comparing with the 5, it is greater than 5, right? So 6 here, so add one number, this becomes 12.9. Now look into the third question. Let me write here. Third question is that 6.4356. 4356. You have to round it off to, up to 3 digits. See, let me write 1 digit, second digit, look into the third digit. Okay, third digit, what is, it is 5. You add one number. When you have a 5, add number. This becomes 3 plus 1, 4. Okay. Now look into the fourth question. 3.567. So let me write first 2 digits without any fear. Okay, now look into the third digit and after the third digit, fourth digit. See this, the number which I have to discard. See the 7, which is greater than 5, right? So what you have to do, you have to add 1. Now look into the fifth question. 847.67. So let me write first 2 digits without any fear. Look into the third digits and the point you have. Don't mind about the point. Now see this digit, which is greater than 5. So you can add one number. So this becomes 848. So 0.00. You have to discard. That's why I can write 00 only. Now look into the sixth question. It is 5.8254. What is this number? Okay, see, that is 5.8. You have exactly 5 here, so add 8.5.83. This is your answer. Okay, let me look into the second set of questions. Round off following numbers to 4 decimal places. So it is given that 4 decimal places, not 4 significant numbers, not significant digits. The previous problem you had to significant figures, you have to round off to 3 significant figures. You have, in this problem you have 4 decimal places, so be careful about this. So let's see, take the first problem, that is 6.284359. So you write the digits before the decimal, right, as it is 6 point. Let me take 6 point I have written. Now look in the 4 places, only target 4 places. 1, 2, 3, 4, only 4 places. Look into it. So I can write 3 digits without any fear. When writing the 4th digit, I have to follow some rules. So see, here you have 5, so what you have to do, you add 1, so it becomes 4 here, 6.2844. We'll see, take the second problem. Second problem is 9.86465. I can write this 9.864 without any fear. Now look into the 4th decimal, digit in the 4th decimal place. So this is 6. You have 6. So after the 6 you have only one digit, that is 5. So you can certainly increase the 4th digit in the 4th decimal place by 1. This is 7. Okay. Let me see the third problem. 12.464762. See, I can write 3 digits, 3 digits in the decimal place, that is 4 6. Look into the 4th digit, look in 12.464. Look into the 4th digit, that is 7 you have. After the 7 you have 6, which is greater than 5, so you have increased the 4th digit in the decimal place by 1, that is becomes 8. This is your answer, right? Very nice. Okay, now the one more set of questions we have on round off. So round off the following numbers to correct to 4 significant figures. 4 significant figures. Okay, let us see the problems. So first problem, 3.626425. This is your problem. See the take the 4 significant figures, 1, 2, 3, 4. I can write 3 significant figures without any fear. So 4 to look into the 4th significant digit. So 4, you have that 2. So which is less than 5. You can't do anything with the 4. So you have to keep as it is. So your the number which is rounded off is 3.264. Now look into the second question problem. 35.46735. I can write 3 significant digits without any fear, that is 35.4. look into the 4 digit. After that you have 7 which is greater than 5, so increase the 6 by 1, that is 7, that is 35.47 is the rounded off figure. Let us see one more example. 0.00032217. Now you should extra careful in this problem. We are not taking any zeros here because we will not consider these as a significant figures. They are only help us to fix the decimal places. Look into here. The first significant, second significant, third, fourth. I can write the first 3 without any fear. 0.00322. Now when writing fourth we should be careful. So which is 7 here, which is greater than 5, right, which is greater than 5, so I can have to increase the digit in the fourth place, that becomes 2. So here it is your rounded off digit. Okay, this is all about the round of the figures. And next topic is we are going to talk about is errors. So this is the common word. We use these words when we perform experiments in physics or any physical chemistry labs. So we are getting the errors there. So let's see what are errors. So numerical methods would generally give the approximate solution. Okay, we are using the methods to get the approximate solution because we are not get the exact solution. So that some problems very difficult to get the solution. That's why we are in approximate methods to get the solution. So why this is we are getting only the approximate solutions? Why can't get the exact solutions? So this is due to the errors mainly in the data or computation. So what are the errors we are facing when we do the computation or any taking down the data? The first type of error is inherent errors. Inherent errors. So what is inherent errors? So errors which already present in the statement of a problem before its solution. So errors which are already present in the statement of a problem. Such errors are called inherent errors. Statement of a problem. We term it as inherent errors. So the another type of error is rounding errors. Rounding errors. So rounding errors arises from the process of rounding. This arises from the process of rounding off. So we have seen, actually we have used the rounding off techniques here. So actual data, if it is actual data, the rounding off figure is this. Rounded off figure is this. So you find so many difference. right? This is while computation, if we use this data, we get error. This is due to this what rounding off technique. So next, the third error is truncation error. So truncation error due to the cutting of an infinite series to finite one. So suppose if you have an infinite series, let me take cos x. So you have seen the Maclaurin series, not Maclaurin, Maclaurin series and Taylor series. I can write the cos x in terms of Taylor series as 1 minus x square divided by 2 factorial plus x to the power 4 divided by 4 factorial minus x to the power 6 divided by 6 factorial. This is a Taylor series at 0, or you can say it's a Maclaurin series of a cos x. This is the infinite terms. We have so many terms after this. So if I cut to n terms, if I cut this sequence to n terms, okay, if I cut to this only up to the n terms, if I write only here up to the n terms only, then I can say this is the truncation error, because you have a actual series, you have a infinite terms, whereas you have a finite number of terms. You don't find the terms which after the nth term. So you will get the, when you take the differentiation, sorry, not differentiation, sorry, the difference between these cos x, and if I Sn of x is the finite number of terms of the cos x, so series. So if you take the difference of this, you will find the error, right? Okay.